Hello, statistics students, and happy Friday to you. I hope this week has been going well for you, and I hope you all have a great weekend. We have another topic today to look at. I know it's Friday, but this isn't that bad. Um, when we're trying to transform variables, there's one more thing we can do. We can combine two random variables. So we've done taking one variable and multiplying, dividing, adding, and subtracting to it, but those are all constants. Multiplying by 2, adding 150. But what if we add or subtract another random variable to it? So it's not a constant, it could be different every time. We're going to take a look at what that does and why you might do that sometimes. It's actually quite common. So, of course, once we do that, we will define and look at the shape, the center, and the spread, and that allows us to then do probability questions. All right, so the first one here. Suppose Mrs. Bolt also has a side hustle. Mrs. Bolt runs a wedding cake business. All right, what if she wanted to describe how much extra money total the Bolts bring in from not only the party bus side business, but also the cake business? We're going to add those two random variables because they each make a different amount of money every week and they're completely unrelated to each other. All right, how much total if we add those? All right, so first off, I've got the summary statistics for the two business. All right, so here X, we're going to call X the party bus money. So we've been using that a lot, so hopefully these numbers look familiar. So the average of X, mu sub X, is equal to $562.50, and the standard deviation, sigma sub X, is 163. Now those little subvariables are really important. Remember, mu stands for the average, but this is the average of X, so we put a subscript of X. This is the standard deviation of X, so we put the subscript of X. But the cake business also has a mean and standard deviation. So we still use mu and sigma for mean standard deviation, but now we give them a subscript of y so we don't get them confused. We use subscripts a lot, so hopefully that clarifies things and doesn't make things more complicated. But there is the average and standard deviation of the cake business. All right, well, how much total are the Bolts going to bring in on a random weekend? So that's going to be this random variable right here. The total is equal to X plus Y. Now we're going to add these two random variables together. All right, now the shape on this one, because this was a discrete random variable way back in the way, we're going to come back to the shape. We can't do the shape in this problem. We can do them in later ones, and you'll see it's real simple, but we can't really do anything with the shape here unless we actually drew a graph or something, but that takes a lot. That's extra. It's Friday. All right, the center. The center is really easy. So the center of my variable t for total is simply equal to the average of the first one plus the average of the second one. Nice and easy. The average of the addition is simply adding up the two averages. So that's nice and easy. So the new average will be 562.50 plus 245.32. So we simply add those together. 245.32. 807 and 82 cents. So on an average week, well, over many weekends, the average amount of money, total money the Bolts bring in was $807.82. Whew, I wish I wasn't making that up. That would have been nice. All right, so let's write ourselves a sentence there. Give me some more space. All right, so if we look at many weekends On average, the bolts would bring in $807.82. All right, now the spread unfortunately is a bit tricky. All right, if we want to find the standard deviation of t, you are not allowed to add the standard deviations. It would be nice if you could, but that's simply not how the math works out. And so we cannot add the two standard deviations. The equation to do it is this. It's the square root of the first standard deviation squared plus the second standard deviation squared. So the mathematical rule is you can't add standard deviations. But you are allowed, we can add what's called the variance. Okay, and the variance is simply the square of the standard deviation. All right, so the variance is equal to the standard deviation squared. So if we want to combine these things, first we square them. That turns the standard deviation into the variance. You are allowed to add those. So we add them up. But then we don't want the variance. We want a standard deviation. And so to go backwards, we undo the square and we square root it, which brings us from a variance back to a standard deviation. All right. The nitty-gritty math, go away. I just want to get rid of the highlighting. Square, square, and square root. There we go. Now we're back. So let's do that with this problem here. All right, so our first standard deviation was 163.46. All right, so we have to square that, plus the standard deviation of y, which was 240.22. So we square that. We are allowed to square those, and now we have to square root it to get back to a standard deviation. So it's a bit of a formula, but it's, again, plug and chug. It's not too terrible. All right, so we're got the square. I'm just going to type that whole thing in square root 163.46 squared plus 240.22 squared. And I already put the square root in there. Hit enter, and we get 290.56. So one thing to point out here is that the standard deviation does always get bigger. All right, so this standard deviation was 163. This one was 240. After combining them, it is bigger. It is 290. Hopefully that makes sense. When you take two random things and you combine them, it gets sort of more random, more spread out, all right, more variable. Now, it doesn't get so variable that you simply add the two standard deviations. It's not quite that spread out, but it does get more spread out. That number will always go up. Okay? Which I should note, maybe I'll write that here. I was going to say it later, but I'm going to say it right now. For the spread, you always add. No matter what. You always add. For the center, sometimes you might add or subtract. Depending on what the problem is saying. All right, here we are adding x plus y. And so the average is you either add or subtract. But for the spread, you always add no matter what. Hopefully it makes sense. If you take a random process and another random process, it's always going to get more spread out when you combine them. So sometimes you will, even if you're subtracting in your problem like our next example, you will always add. All right, let's do one of those real quick. And this time we are going to do shape. All right, we are going to do shape. So here's our scenario. Male dogs are usually bigger than female dogs. Suppose we choose a random male husky and a random female husky, and we subtract their weights to find the difference. All right, how much bigger is one of them than the other? We're going to let x equal the weight of the male and y equal the weight of the female. Use the summary statistics to describe D, which is going to be x minus y, the difference in their weight. We're going to do male minus female. D is going to be our new random variable, the difference. All right, so here's our summary statistics. The male huskies, the shape is normal with an average of 58 and a standard deviation of 61. So here are my husky weights right here. They're normally distributed, where the average is 58 and the standard deviation is 6.1. So plus 6.1 minus 6.1 over and over and over again, right? My female huskies, they are also normally distributed. So here's my visual here. And then their center is 45, and then they're adding 4.3. So plus 4.3 over and over again, minus 4.3 over and over again. Now, I'm going to take a random female husky, there, and a random male husky over there. And I'm going to take their weights and subtract them, and then that difference would turn into a new distribution. And if I did that over and over again for many, many random male and female huskies, the end result would also be normal. So a normal plus or minus another normal, shocker, is equal to a normal. So we know the shape is going to be normal. All right, the other ones we've already done. So the center. So the average of D, the difference, is going to be the average of the x, this time minus the average of the y, because we're finding the difference between them. So we do subtract the averages. All right, we expect the usual difference to be 58 minus 45. All right, we're expecting a difference of 13 pounds. All right, so we expect the difference to be centered around 13 pounds. Now, how spread out is this going to be? All right, so here's where we got to use our formula. It's going to be the square root of the standard deviation of x squared plus the standard deviation of y squared. But again, we do add them. Even though this is a subtraction problem, all right, I'm with you, it's a subtraction problem, we still add the variances. It still becomes more spread out because we're taking two random things and combining two random things. So the square root of 6.1 squared plus 4.3 squared. That is going to be our spread. So the standard deviation of D is equal to, the square root of 6.1 squared plus 4.3 squared is 7.46 pounds. All right, as you can see, it got more spread out. 6.1, 4.3. It is more spread out. Well, now that I know the shape is normal, I know the center is 13, I know the standard deviation is 7.46, I can ask you one of these questions. Suppose we choose a random male and a random female husky. What is the probability that the male husky is more than 5 pounds heavier than the female husky? That means, what is the probability that D is greater than, I guess, or equal to 5 pounds? All right, that's that the male husky is more than 5 pounds. Well, if I draw that over here, 5 pounds is over here somewhere. What are the chances that we are greater than 5 pounds heavier for the male husky? Well, that's a normal CDF. So I'm going to come over here to my calculator and go normal CDF. So second. So again, yours is in a different place. You have a different calculator, but you should know where normal CDF is by now. They ask all the same things. So the lower, well, my lower is 5. That's my lower boundary. Let's see, I colored in to infinity, right? To the right, so that's 9999999 is my upper. The mean, 13, right there is the center. And the standard deviation is right here, 7.46. So now that we've described the shape, the center, the spread, we can fill in everything for normal CDF. 86%, 0.86, I'd round that up, I suppose, so 0.86. So there is an 86% chance, if we have a random male husky and a random female husky, that the male will be more than 5 pounds heavier. There is an 86% chance that if we choose a random male and female husky, that the male will be more than 5 pounds heavier than the female. All right, hopefully that's making some sense. I got a couple practice problems for you that do this exact same thing. It is on sapling. I would like you to do that here today. It's not really homework. I think you've got time. It's only 4 problems. It's basically 2 scenarios like what we just did. So head over to Sapling and try those out. And I hope you all have a great, great weekend. And hopefully, I will see you on Monday. Bye, everybody.